Hello, welcome to Machine Translation. Before we start this specific topic, let's see a broader field in computer science, natural language process. It includes the four main applications: machine translation, information extraction, text summarization, and dialogue system. The first example here is about information extraction. The machine retrieves a text and gives back information such as addresses and numbers. The bottom one is about dialogue system. As you can see here, the machine works like a secretary. For the basic structure of machine translation, computer works like this. It understands the language or text, processes, and generates into another language. Here are some classical approaches to machine translation. The first one is direct machine translation, which literally means translation word by word. Next is about transfer-based approach, and it relies on parse tree like this. And interlingua-based translation. Its core is to convert the meaning representation into an output sentence. The most important method today is statistical machine translation. The first application is IBM model, and on the basis of IBM model, we have phrase-based translation model, which is widely used in many translation machines, including Google Translate. Let's start with IBM model. For example, we want to translate sentences from French to English. This notation here represents the language model, and this one represents the translation model. As you can see, this one estimates conditional probability of any English sentence E given a French sentence F. And this one finds out the English sentence with the probability of E on the condition of F reaches its maximum value. One important concept in IBM model is alignment. Let's look at this example. There is an English sentence and a French sentence. L is the length of the English sentence, and M is the length of the French sentence. One possible alignment here is 2, 3, 4, 5, 6, 6, 6. It means the first sentence in F, the word here goes to the second word in sentence E, and this one goes to this one goes to this one, and these three words go to the sixth word in E, which is implemented. And here is another alignment, 1, 1, 1, 1, 1, 1, 1, which means all the word in sentence F goes to the same word in E, and obviously it's a bad alignment. Here is another notation, Q of I on the condition of JLI is the probability that the jth French word is connected to the th English word, given sentence lengths of E and F are L and I respectively. To generate a French string F from an English sentence E, the first step is to pick alignment A from A1, A2 to AN with probability Q of AI on the condition of G, L, M, and times them together. The second step is to pick the French words with probability. Remember that this is the translation model, and here is the final result. Similarly, we can find the alignment by finding out the maximum of the final result. Here is an example. When J is 3, which is go in the sentence F, go can be aligned to now. Here, to the dog or barks. When go is to now, the result is this one times this one, which is 0.01. When go is the result is this one times this one, which is 0.08. When go is dog, the result is this one times this one, which is 0.1. And when go means barks, the result is this one times this one, which is 0.06. As we can see, the maximum number is 0.1. So A3 is 2, which is dog here. Then here is an algorithm indicating how to calculate T, which is the translation model probability, and Q. But I will not talk about this mathematics formula here. Let's see the phrase-based translation model. What is phrase-based translation? Here is a Mandarin example. Australia is with North Korea have diplomatic relations that few countries one of. This sentence makes no sense because it is translated by word-based model. However, phrase-based model will solve the problem of ordering and gives us the correct answer as one of the few countries. First, we have the alignment matrix of both P of F given E and P of E on the condition of F. What we need to do is to find the intersection of the two alignments at the starting point, as you can see here. And here is how we get the value of T. According to this formula, we can see in this example, the German word here can be translated into different English phrases. When T reaches its maximum value, we can know that the proposal instead of a proposal or this proposal is the best translation. But this is only part of the result. In fact, the score is consisted of logarithm of T, the logarithm of Q, and this notation of distortion model. And this one is usually a negative number. We can get the best translation by the highest score. Finally, we have to decode the phrase-based translation to make it display in front of us. Here is an example sentence. The most important part of decoding is derivation. A derivation Y is a finite sequence of phrases. And the P are members of this P, the set of all phrases for a sentence. For any derivation, we use E of Y to refer to the underlying translation defined by Y. Here is an example. y equals to 1 through 3, we must also 7 through 7 take 4 through 5 this criticism, 6 through 6 seriously. This one is a starting point, this one is the ending point, and this is the English sequence of words. From this derivation, the translation should be we must also take the criticism seriously. It is perfect. However, there should be many different derivations. So how do we know which one is valid? Here are the rules. The first one means the phrase must be a member of P. And the second one says each word is translated exactly once. The important one is the third. D here means distortion limit, which is typically 4. Why do we need this? The reason of D is that for too far positions, the translations tend to be poor. So I need a D here. And in this one, T of PK is the endpoint of a phrase, and P of K plus 1 is the first point of the next phrase. Let's see the example here. The absolute magnitude of this one is 3 plus 1 minus 7 is 3. It's less than D, which is 4. Next one is 7 plus 1 minus 4, which is 4, equals to D. Next, it's 5 plus 1 minus 6, 0, less than 4. So this is valid. If you have interest in natural language processing, or you want to write a program to write summaries for you in writing workshop, you can visit this website for further exploration. Thank you.